Jai Hind, myself Dr. Alok Vardhan. Currently, I am working as an assistant professor in the Department of Mechanical Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. Through this video lecture, I will discuss some important topics of the subject renewable energy resources, and its code is KOE 074. In this lecture, I will discuss one of the important topics about wind energy. So, in this lecture, first of all, I will discuss introduction of wind energy and its applications. Introduction of wind energy and its sources. Then, what is wind power? I will discuss wind power by the help of momentum theory. Then, I will discuss different types of wind turbines, means classification of wind turbines. Then advantages, disadvantages, and environmental impact of wind energy I will discuss. Then what is the wind energy scenario in India and site selection for wind energy. So in this lecture I will discuss these topics. What is wind energy? So basically, wind energy is an indirect form of solar energy. Okay, they are caused by the uneven heating of Earth's surface and its rotation. So this is the due to the temperature difference between the Earth's surface and its rotation, wind is flowing. The wind can be classified into two categories. First one is local winds and second one is planetary wind. What is local wind? So local wind is caused due to the unequal heating and cooling of ground surface and water bodies at day and night. During daytime, land is hotter than sea, so due to which air near the surface becomes hot faster than sea, which creates a pressure difference between surface and the seashore. Then what happened? Due to this difference in pressure, cool air at high pressure zone from sea will move towards the land, and these breezes are known as sea breeze. Okay. Then what happened? Its vice versa action is taken place at night, and now air starts to move from surface to sea, and such breeze are known as land breeze. Means when air will start flowing from sea to surface, so this is called sea breeze, and when air is flowing from surface to sea, then it is called land breeze. Then second type of wind is planetary wind. What is planetary wind? These are caused due to unequal heating of the Earth's surface near the equator and the northern or southern poles. Because of this, warm air from tropical regions flows upward and moves towards the poles, and cool air from poles moves toward the tropical region. So due to this, wind is flowing, and this type of wind is called planetary wind. Now I will discuss what is wind power, momentum theory. So if m be the mass of the air moving with velocity capital V per unit time, then the power associated with it may be calculated by P is equal to half m v square, where m is the mass of the air and v is the velocity of the air. So power is equal to half mv square. This is equation number 1. If A is the cross sectional area of the wind stream and rho is the density of air, then mass flow rate is calculated by M is equal to rho A V, where A is pi d square by 4. This is equation number 2 and this is equation number 3. Here rho is the density of air in kg per meter cube. A is the cross sectional area of the wind stream in meter square, and V is the air velocity, and D is the diameter of the wind stream. So by putting the value of M in equation number 1, we will get P is equal to half rho A V cube. This equation. By putting the value of M in equation number 1, we will get P is equal to half rho A V cube. Now, if the diameter of the wind aero turbine be capital D, then A is equal to pi d square by 4. So, by putting the value of A in this equation number 4, we will get P is equal to half rho pi by 4 d square V cube. In short, we can write P is equal to half pi rho d square and V cube. This is the total wind power. By using equation number 3, we will calculate total wind power. So, in this equation, the wind power is directly proportional to density of the air, diameter of the aerofoil, and velocity of the air. So, the amount of power transferred by wind is directly proportional to the density of the air, wind speed, and area of the opening as given in equation number 3. So, by increasing the air velocity, we will get more wind power. By increasing the diameter of the wind stream, we will get more wind power. Okay. Now, I will discuss classifications of wind turbine. So, basically wind turbine may be classified into two categories. First one is horizontal axis wind turbine and second one is vertical axis wind turbine. This figure represent horizontal axis wind turbine and this figure represent vertical axis wind turbine. Here the axis of the rotation of the wind turbine is horizontal. So, this is called horizontal axis wind turbine, and here the axis of the rotation of the rotor is vertical. So, this is vertical axis wind turbine. Now, I will discuss one by one what is horizontal axis wind turbine, their classification, and what is vertical axis wind turbine and their classification. So, first one is what is horizontal axis wind turbine. So, the orientation of these turbines are kept along the horizontal axis and can be divided into monoblade machine, twin blade machine, three blade machine, and multi blade machines. Okay. So, we can say that ki horizontal axis wind turbine is classified into these four categories: monoblade, twin blade, three blade, and multi blade. What is monoblade machine? This figure represent the monoblade machine. Here there are only one blade. Okay. So, these are simple in construction, installation is easy and having low cost and easy maintenance, can produce low power of 15 kilowatt to 50 kilowatt, generally used for pumping, battery charging, and other agricultural purpose. So, this monoblade machine is the simplest type of wind thermal power plant. Second one is twin blade machine. Here there are two blades, blade number 1 and blade number 2. So, it is called twin blade machine. So, these machines are rated from 1 megawatt to 3 megawatt. In other words, we can say that by using the twin blade machine, we can generate power from 1 megawatt to 3 megawatt. They are less costly than three blade machines, but having large vibration during running. So, basically these two blade machines are cheaper than three blade machine, but costlier than single blade machine, and these machines produce more vibration during running. This vibration is caused due to unequal force at lower and vertical position of the rotor. So the main disadvantage of twin blade machine is it produces more and more vibrations. Then another one is 3-blade machine. Here there are 3 blades, 1, 2 and 3. So it is called 3-blade machine. In this machine, these are high in cost but also more efficient. These machines are rated from low capacity 15 kilowatt to higher capacity of 3 megawatt. So by using this 3-blade machine, we can produce the power between 15 kilowatt to 3 megawatt, and this is more efficient compared to single blade and twin blade machine. And then another one is multi-blade machine. Here there are number of blades, blade number 1, 2, 3, 4, 5 and 6. So we can say that if number of blades are more than 3, it is called a multi-blade machine. So here having high starting torque characteristics, these machines are used for pumping of water. So this type of machine can be used for pumping of water. And this type of machine require high starting torque. Okay. Then another type of wind turbine is vertical axis wind turbine. So basically in this turbine, these turbines are mounted on ground level and their blades go from top to bottom. These are basically of 2 designs, Savonius type rotor and Darius type rotor. So vertical axis wind turbine is classified into these 2 types, Savonius types and Darius type. So in subsequent slide, I will discuss one by one what is Savonius and what is Darius type wind turbine. In Savonius type rotor, and this is Savonius type rotor, in such turbine, S-shaped rotor, this is S-shaped rotor, look like this, S-shaped rotor, also called S rotor, is supported at top and bottom of 2 circular plates. Okay, this is 1 circular plate and this is 2 circular plate. The A halo cylinder is sliced into 2 pieces and each of these halves fixed to a vertical axis with a fixed gap. Then what happens? The air strikes on concave side, circulating through center of rotor and glides over the convex surface of the other blade. The tip of the speed ratio of turbine is 1 to 2 and efficiency lies between 15 to 30%. These rotors having low RPM up to 100 RPM, and these are basically useful for agricultural purpose, not for electricity generation. So by the help of Savonius type vertical wind turbine, we can use this type of turbine for agricultural purpose. By the help of this turbine, we cannot produce any electricity. Then another one is Darius type rotor. This is Darius type rotor. In this turbine consists of a number of curved aerofoil blades mounted on a vertical rotating shaft या framework. The curvature of the blades allows the blade to be stretched only in tension at high rotating speed. When the Darius rotor is spinning, the aerofoils are moving forward through the air in a circular path. Then what happens? Relative to the blade, this oncoming airflow is added vectorally to the wind so that the resultant airflow creates a very small positive angle of attack to the blade. And these turbines are available in size of 4 megawatt to 14 megawatt capacities with efficiency of 35% to 40%. Then what is the advantages of wind energy? So basically it is renewable and free of cost. These are the some advantages of wind energy. So the first advantage is it is renewable. Renewable matlab it is inexhaustible in nature, and it is free of cost. There is no cost for producing this energy. Then pollution free and not release toxic gases. So the second advantage is it is pollution free, yani ki it is best renewable energy resources for environmental point of view, and not release any toxic gases. Have low maintenance cost, matlab it this type of wind energy, this type of wind turbine requires less maintenance cost and does not require any transportation also. Another advantage is it does not require consumption of water. Here in this type of turbine, there is no use of water. Then what is disadvantages of wind energy? The first one is high capital cost. Means ki initial cost for installation of wind power plant is very high. It requires huge amount. Okay. Then having low efficiency, 10 to 45%. Means the efficiency of wind thermal power plant is also very low. It lies between 10 to 45%. Another disadvantage is depends on location, season and wind speed. Basically, by the help of wind, we can produce electricity. So, location is very important factor for wind power plant. Another one is season and wind speed. So, some particular amount of wind speed is required for producing the electricity. So, these three factor, location, season and wind speed is required for wind energy power plant. Then another disadvantage is causes sound pollution. So it is when a rotor is rotated with the help of wind, so it produces noise. So we can say that causes sound pollution. Storage of wind is not possible. We cannot store wind. So then what is the environmental impact and limitations of wind energy? The first one is wind turbines can safely within the range of 5 meter per second to 24 meter per second wind speed. So means ki wind turbines can safely work within this range, 5 meter to 24 meter per second. Below the 5 meter per second, not possible, and above 24 meter per second of wind speed, it is not safe. Okay. So another limitation is proper land is required for installation of wind turbines free from tall buildings and towers, etc. So we can say that ki where wind power plant is installed, it is free from tall buildings. It should be free from tall buildings, towers and etc. Okay. Then fatal collisions of birds caused by rotating turbine blades. So this is one of the environmental impact, ki fatal collisions of birds due to rotating turbine blades. Then what is the wind energy in India? Yeah, we can say that what is wind energy scenario in India. So basically, India ranks 5th amongst the wind energy producing countries of the world after USA. Okay, USA, China, Germany and Spain. Yani ki USA holds first rank in wind energy generation. After then, China, Germany and Spain. And our country, India, ranked 5th among the wind energy production. As of 31st December 2013, the installed capacity of wind power in India was 20,149 megawatt. Okay, means कि एज ऑफ 31 दिसंबर 2013 wind power production in India is 20149 megawatt, means 20,149 megawatt, and it is mainly spread across Tamil Nadu. Here production rate is 7,154 megawatt. Then Gujarat, here production is 3,093 megawatt. Then Maharashtra, here production is 2,976 megawatt. Then Karnataka, here production is 2,113 megawatt. Then Rajasthan, here production is 2,355 megawatt. Then Madhya Pradesh, here wind energy production is 386 megawatt. Then Andhra Pradesh, here wind energy production is 435 megawatt. Then Kerala 35.1 megawatt, Odisha 2 megawatt, West Bengal 1.1 megawatt, and other states 3.20 megawatt. Means in 20,145 megawatt, the first state which contribution is more compared to other state is Tamil Nadu, and the production rate is 7,154 megawatt. Then it is estimated that 6,000 megawatt of additional wind power capacity will be installed in India by 2014. Okay. Wind power accounts for 8.5% of India's total installed power capacity, and it generates 1.6% of the country's power. Means कि wind power contributes 1.6% of the country's power demand. Means okay. Then what is site selection? What is the site selection for wind thermal power plant? So it is one of the important important consideration for installation of wind power plant is site selection. So following factors are to be considered for selection of good site for wind power generation. So first one is high annual wind speed, should have an average wind speed in the range of 6 meter to 30 meter per second throughout the air. So the site should be in such a way that the average wind speed in the range of 6 meter to 30 meter per second throughout the year. Then historic data of wind mean speed must be collected for average velocities during the year to select the site for availability of wind velocity needed for installation of wind farms. Okay. So the one thing we should keep in mind that average mean speed throughout the year. This is also an important factor for a site selection. Then tower design must be adequate to withstand maximum wind speed observed in the last few years in the installed area. The other important factor is tower design. Okay. Then no tall obstruction for a radius of 3 km. So this is also an important factor. No tall obstruction for a radius of 3 km. Okay. Open plain या open shore, the site selection should be such a that open plane, means it requires open planes, open plane and open shore area. Top of a smooth, well-rounded hill with gentle slopes. And the last criteria is mountain gap, which produces wind funneling. So this is some important criteria, important factors for site selection. So the main important factors is, first one is wind speed. It should lie between 6 meter to 30 meter per second throughout the year. Then average main speed, first one is wind speed. Wind speed, it should lie between 6 meter per second to 30 meter per second. Then second important factor is wind mean speed throughout the year. Then third one is tower design. Tower design also plays an important role. Tower design. Then fourth one is open plane and open shore area. Open plane and open shore area. Then fifth one, mountain gap. Mountain gap. So these are the important factors for site selection. Okay. So so here you will see here we have seen that wind turbines is classified into two types, horizontal and vertical. So this is horizontal axis turbine and this is vertical axis turbine. So here the rotation of the blade, is rotated about this axis, and this axis is horizontal. Okay, so this is called horizontal axis turbine. Or here the axis of the rotation of the blade is vertical. So this type of turbine is called vertical axis turbine, and these two turbines are used for production of electricity with the help of wind energies. So this is all about for this lecture. Thank you for watching.